So let's discuss energy flow in chemical reactions, exergonic and endergonic reactions, catabolical reactions, anabolical reactions. So here is a very complex molecule, right? It could be carbohydrates, could be protein, could be fat. It has a potential energy. And the energy is also stored within the energy-yielding bonds. So when this molecule goes through a reaction, let's say it's a catabolical reaction, right? You're going from poly to mono, it releases energy. You release energy, let's say in the form of ATP. Energy is being released because the energy is stored within the chemical bonds. So this is exergonic reaction. Here's the exergonic reaction. So you start with your reactants and you end up with your product. Your reactants has more potential energy and your product has less potential energy, because here is energy within the molecules and also energy stored within the bonds. Here just the molecules by themselves. So the products have less potential energy. It is a exergonic catabolic reaction. And this is a spontaneous reaction. So here's endergonic reaction. In endergonic reaction, you absorb energy, you store energy. So you start with something that is simple in this case. So this is your reactants, something that enters the reaction, right? And now you're going to increase the potential energy. Here's the less potential energy, here's more potential energy, here's less potential energy. So you start with the reactants that have less potential energy, and now you can use, hypothetically, this energy to put it into work and to build something that is more complex. So you see, we finished with what we started with. So these reactants, by using energy through endergonic, you're storing energy here, you're storing energy back in the bonds. And again, let's say if it's a glucose molecules or proteins or fats, so you're building something, you're building a product. So this is a anabolic reaction, like you're building muscle, and this is endergonic reaction. So you need energy to build energy. You start with the reactants and you end up with products. So here, your reactants have less potential energy, but here, your reactants have more potential energy. You just have to look at it from different perspective. This is a spontaneous reaction, because everything wants to go towards disorder, towards entropy. That's a disorder of the system. And here, reaction is not spontaneous. You need to use energy to build something. But you're storing energy back in the yielding bonds. And this is what I see the student struggles with the chemistry part with anatomy and physiology course.